Given situation, a block of mass m is placed on the rough horizontal plane. So it means the block of mass capital M which is placed on the rough horizontal floor, and the mu coefficient of friction is a mu is a 0.75. Then find the work done by minimum force which is required. Then we know the minimum force जो requirement है, that is a suppose at the angle theta, then the F cos theta is equal to friction, that is a minimum requirement. And in this situation normal reaction is equal to mg minus the component of this force is F sin theta. Then the F cos theta is equal to mu, normal reaction is mg plus F sin theta, and we know the F equal to, it is a mu mg, that is divided by cos theta plus mu sin theta. If we maximize this value of the cos theta plus mu sin theta, then F will be minimum. And for the minimum value of the theta, if the d by d theta of this term is equal to 0, so it is cos theta plus mu sin theta, that equal to 0, then the sin theta equal to mu divided by root of 1 plus mu square, and the cos theta equal to 1 root of 1 plus mu square, and the minimum force which is required to just pull the block is a mu mg, and the divide by अंडर रूट ऑफ 1 प्लस म्यू स्क्वायर. तो हम सॉल्व करेंगे तो इसका वैल्यू ये आएगा, और इस वैल्यू के अकॉर्डिंग इसका डिस्प्लेसमेंट इस साइड, द डिस्प्लेसमेंट ऑफ द ब्लॉक is suppose s, then the work done by this minimum force is equal to F s and the cos of the theta. Theta is the angle between the applied force and displacement. Then we know the work done is equal to, force is a mu mg under root 1 plus mu square, and that is displacement is suppose s, and the cos theta is a 1 divided by under root 1 plus mu square. Therefore it is a mu divided by 1 plus mu square, and that is mg into s, and mg is m is a given, m is equal to 1 by 3. So it is a 1 by 3 multiplied by g is a 10, and displacement is a 5 meter, and the value of the mu is a 0.75 which is given. So I think it is a mu is a 3 by 4, mu equal to 3 by 4. If you put the value the 3 by 4 divide by 1 plus 9 by 16, and that is a 50 by 3, then it is a multiply by 50 by 3 multiply by, this term becomes the 25 by 16 means 12. So it is a 25, 2 and 3, 4. So the work done equal to 8 joule. Therefore the correct option is the first one. One situation, the spring is compressed by distance a on the rough surface, and the system is released. The block again comes to instantaneous rest when the spring is elongated by distance b. Then the correct option choose करना है. तो एक तो वर्क डन बाय स्प्रिंग निकालना है दोनों में, या कोफिशिएंट ऑफ फ्रिक्शन निकालना है. Then we know it is a compressed by a. So stored potential energy in the spring is a half ka square. Half ka square is equal to the further, it is a compression के बाद जो extension हुआ, that is half of k b square. But in this process the work done by friction is a जो कि डिक्रीज हुआ है, या यूँ कहते हैं कि इस साइड इंक्रीज हुआ है, या यूँ कहते हैं कि माइनस ऑफ म्यू एम जी एंड द टोटल डिस्प्लेसमेंट इज ए प्लस बी. इट इज अ माइनस म्यू एम जी ए प्लस बी प्लस हाफ के स्क्वायर. सो द नेट इज इक्वल टू हाफ के बी स्क्वायर. यदि इस फ्रिक्शन को मैं, वर्क डन बाय फ्रिक्शन इज अ नेगेटिव, इसको राइट हैंड साइड ट्रांसफर कर दूँ तो इट इज अ म्यू एम जी total displacement is a plus b. Then work done by the spring on the block, that is the difference of these two terms, and here the option is half k a minus b का whole square and the half k a square plus b square, both are the incorrect. Then यदि इसका coefficient of friction calculate करें तो इसके according this is a half of k a square minus b square, that is equal to mu of mg a plus b. Factor करें में a minus b के, so it is a half of k, factor is a plus b and a minus b, and that is equal to mu mg. Multiply by a plus b को cancel कर लें, then the value of the mu is equal to k multiply by a minus b divided by 2 mg, and the coefficient of friction is a k a minus b divided by 2 mg. So the correct option is the third one. Block of mass is a 0.5 kilogram and the applied force is a 20 Newton and the spring constant is a 40 Newton per meter. Natural length 0.6 है. This force is applied up to the 0.25. It means the displacement is equal to 0.25. So what is the work done by applied force? Work done by applied force is a force into displacement, that is a 20 multiplied by 0.25, so it is a 5 joule. This 5 joule work done is stored in the energy, potential energy of the spring. That means when force is removed, then the velocity of the block is maximum at this situation and it is further compressed by x. So this work done 5 joule converts into potential energy of the spring. Spring का force constant 40 and the compression is a x. So x square equal to 1 by 4. So x equal to 1 by 2 means 0.5 meter. It means x का value, this value of the x is 0.5. इसका 0.5 मीटर कंप्रेस होने के बाद रेस्ट में आएगा. इसका वॉल से इसका डिस्टेंस, मिनिमम डिस्टेंस, व्हाट इज द मिनिमम डिस्टेंस ऑफ द ब्लॉक फ्रॉम द वॉल, that is a 0.6 minus 0.1 is 0.1 meter. So the correct option is a 10 centimeter. In this question the mass is attached to the spring and the spring is stretched by the x when the force F and then released. After being released the mass comes into rest at the same position and इसी position पर rest में आ रहा है. इसका displacement side x, then दोबारा इसी side x है. Then what is the work done by the applied force? Work done by applied force is F into x as well as friction का work done, that is equal to जाते वक्त opposite direction में, आते वक्त भी displacement के opposite. So the work done by friction is equal to the total displacement, total work done fx and fx, that is a minus of twice of fx, and the total work done on the block is equal to change in kinetic energy, and the change in kinetic energy equal to 0. So the F into x equal to twice of F into x. Therefore F equal to twice of friction force equal to mu into mg. Friction force equal to mu into mg. So it is twice of mu into mg. यहाँ coefficient of friction पूछा गया, so coefficient of friction equal to F upon twice of mg. So the correct option is this one, inverse of this one. Inverse of this one means it is a correct option is third one. The question: the girl start sliding along the curved water slide without friction from the height h. It means the initial height is h and final height when this is a bottommost point, this is a h by 5. So the net vertical height is a h minus h by 5. So it is a 4h by 5. So velocity when it leaves the slide, it is a velocity equal to root of twice of g into vertical height is a 4h by 5. So velocity equal to under root 8gh by 5. In this situation, the velocity in the upward direction is a v sine theta. Then we know vertical height, this vertical height y equal to this v sine theta whole square divided by 2g. So y equal to sine square theta, and the v square is a 8g h by 5. ऑलरेडी 2g है, 2g से 8g को कैंसिल किया, इट इज़ अ 4h by 5. सो द इनिशियल टर्म इज़ अ 4h by 5 मल्टीप्लाई बाय साइन स्क्वायर थीटा. So the correct option is a sin square theta. Correct option is a 4h by 5. It means first option is correct. In this question, there is two particles which are projected with the help of the spring. We know the spring constant is a k, then the half k x square equal to half mv square. Therefore, the horizontal velocity in case of the spring is a v equal to x root k by m. The horizontal velocity is depends on the compression. First case, the compression is at 2 centimeter. In the both situation, one of the thing is common, that the vertical height is same. Therefore, the time of flight is equal to root 2h by g. And the time of flight is same. Therefore, the range depends on the time of flight as well as the velocity in the horizontal direction. Then range equal to velocity into time of flight. Time of flight in the both the cases is same. In the first situation, the range equal to 2 meter, and the range is proportional to the velocity, and velocity is also proportional to what? Both the situation k by m. The k by m is the same, and the velocity is proportional to the compression of the spring. So range is proportional to the x1, and the second case the range is proportional to suppose x2. In the first case, what is the range? Range is equal to 2 meter. Therefore, the compression is also compression in the first case in the problem horizontal 2 centimeter. So it is a 2 centimeter. In the second case, range is exactly 5. Therefore, the compression is suppose x. Then 2 by 5 is equal to 2 by x. Then very simple, it is a x equal to also रेंज जब 2 लेना है तो 2 सेंटीमीटर कंप्रेस करना, तो रेंज जब 5 मीटर लेना तो इट इज़ अ 5 सेंटीमीटर. So the correct option is a 4 centimeter. I think chain of length L and the length on the table is a L minus B. I think table is a L minus B. Then the remaining chain is a B, because the total length of the chain is L, and when the whole chain is a slip and the last link at the B, then finally calculate the velocity of the chain when the end reaches at the B. It means the whole chain when reaches at the B, then the scenario is this upper part, just like upper part, reaches at the B, reaches at this position, and that part is a length is a L minus B, and the total length is a L, and the center of mass of this L minus B is at this horizontal level. Then what is the displacement of this part? Displacement of this part is L minus B. When the L minus B reaches at this position, then what is the displacement in the downward direction? That suppose the total length is L and this angle is suppose theta. This is L sin theta. But center of mass, the position of the center of mass is L sin theta minus half of this L minus B by 2 sin theta. That is the displacement of this part, जो कि हॉरिजॉन्टल टेबल के ऊपर रखा है, उस पार्ट का डिस्प्लेसमेंट नीचे की तरफ इतना हो जाएगा. अब हम यूँ कहें कि मास ऑफ द टोटल मास इज m, टोटल मास इज m अपॉन L इंटू L माइनस B इंटू G, एंड द डिस्प्लेसमेंट इज ऑफ द सेंटर मास. सेंटर मास पहले यहाँ था, अब इस पार्ट का मास इस जगह आया है, एंड द डिस्प्लेसमेंट इज द साइन थीटा. कॉमन ले लेते हैं. इट इज़ L माइनस B बाई 2. यदि 2 LCM लेता हूँ तो 2L माइनस L, इट इज़ L, एंड माइनस माइनस दिस इज अ प्लस, सो इट इज़ L प्लस B बाई 2. So it is L plus B by 2, and the whole potential energy converts into the kinetic energy, and kinetic energy of the chain is half m v square. M cancel with the m, and the 2 cancel with this 2, and the velocity का square is equal to L minus B, and L plus B is L square minus B square, and that is G sin theta, and that is divided by L. G is also, so V equal to root of G sin theta divided by L, and in the bracket L square minus B square, and I think it is G sin theta by L. G sin theta by L in the bracket L square minus B square. It is correct. Is the third one. This question: body of mass 2 kg move in the one direction in the presence of force which is described by the potential energy graph. It means change in potential energy in convert into kinetic energy. At the x equal to 5, what is the potential energy? That is a 2 joule. But according to this triangle, this side is 1 to 3.5. It is 2.5, and the height of triangle is I think 10. Therefore, suppose this angle is theta, then the tan theta equal to 10 by 2.5. 10 by 2.5 is 4. And we want to find the potential energy at the x equal to 2. At the x equal to 2 means that is 0 to 2, means that is a 1.5. If this is a 1.5, that is a 1.5. That means the height is suppose y, means potential energy is y. Then y upon 1.5 equal to tan theta, and tan theta is equal to 4. therefore y equal to 6. That means the potential energy is equal to 6 joule. Then change in potential energy 6 minus 2 is equal to change in kinetic energy, and change in kinetic energy is half into 2 into velocity square. Therefore the 4 equal to v square, therefore the v equal to 2 meter per second. Therefore the correct option is third one. हाँ, अगले सिचुएशन में एटमॉस्फेरिक जो भी रेजिस्टेंस है उसका वैल्यू F इक्वल टू माइनस के वी, जैसे हम पढ़ते हैं विस्कस फोर्स में. देन व्हाट इज़ द मैक्सिमम पॉसिबल रेट ऑफ हीट लॉस. रेट ऑफ हीट लॉस से पहले हम ये समझें कि इसमें एक स्टेट ऐसा आएगा जब वेट जो है एग्जैक्टली रेजिस्टिव फोर्स के इक्वल हो जाएगा. देन वेलोसिटी ऑफ द ऑब्जेक्ट बिकम्स द कांस्टेंट, दैट इज नोन एज टर्मिनल वेलोसिटी. और उस टाइम जो भी वर्क डन करेगा ग्रेविटी, दैट विल बी द लॉस इन द हीट में लॉस हो या किसी भी अदर फॉर्म में लॉस हो, मीन्स दैट इज द लॉस ऑफ द एनर्जी. दैट मीन्स द लॉस ऑफ द एनर्जी इज इक्वल टू द वर्क डन बाय ग्रेविटी. इट मीन्स वर्क डन बाय ग्रेविटी एंड द लॉस ऑफ एनर्जी, दैट इज अ पावर. इसका मतलब जितना पावर जो लॉस हो रहा है या जो भी पावर है वो लॉस हो रहा है, और पावर इज ड्यू टू द ग्रेविटी. दैट मीन्स द पावर इक्वल टू फोर्स इनटू वेलोसिटी. इसका मतलब मैं यूँ कह दूँ कि पावर इज इक्वल टू या रेट ऑफ द हीट लॉस इज इक्वल टू द फोर्स व्हेन द टर्मिनल वेलोसिटी अचीव. टर्मिनल वेलोसिटी जिस टाइम अचीव होता है उस टाइम फोर्स और वेलोसिटी का जो प्रोडक्ट है दैट विल बी द मैक्सिमम पावर लॉस, एंड द मैक्सिमम पावर लॉस ही पूछा गया है. देन द फोर्स, वी नो फोर्स इज इक्वल टू mg, and the velocity, terminal velocity equal to when the mg minus kv, the net force on the body equal to 0, then terminal velocity is equal to mg by k. If we put the velocity, terminal velocity, then it is mg by k. Therefore the power, maximum power loss, it is m square g square by k. I think m square g square by k is the first option is correct.